Have you ever wondered why silver is so much riskier than gold? If you only look at the average return, they can look surprisingly similar. But if you live through the price path, the experience is completely different. Silver swings harder. It spikes up faster and drops faster, which can be very bad for your sleep. Mathematically, we would call this a high standard deviation. In this video, we build that idea from scratch, and once you see it, you will never again trust same average return as a risk comparison. Now let us start with the simplest idea. We have a random variable. Call it x. In finance, x could be, for example, a daily return. In the last video, we learned one summary number, the expected value. We write it as e of x. For simplicity, we will call it mu in this video. Two assets can have the same expected value and still feel totally different. Gold and silver are a perfect example. Even if their long-run average returns are close, one of them moves around that average much more. So we need a second summary number, not the center of the distribution, but the spread. This tells us how far outcomes typically sit away from the mean. In finance, this is volatility, and this is precisely what variance and standard deviation measure. Let us build it. Take one possible outcome of x. The deviation from the mean is x minus mu. If x is above mu, that deviation is positive. If x is below mu, it is negative. Now a natural idea would be, let us average these deviations. But something strange happens. The positives cancel the negatives because mu is the balancing point. So raw deviations are useless as a spread measure. We need a way to turn distance from the mean into something that never cancels. There are two classic choices, absolute value or squares. Finance usually uses squares because squares make the math clean, and because big deviations matter more, so we square the deviation. We take x minus mu and square it. Now negative and positive deviations both become positive, and large moves get punished more, which is exactly what we want for risk. Now we want to average this deviation over all x. For this, we take the expected value of this deviation and call it variance. In other words, variance is the average squared distance from the mean. If x is discrete, this is a weighted sum. You look at each possible value xi. You subtract mu, you square it, and you weight it by the probability pi. This leads to this formula. If x is continuous, it is the same idea with an integral. A smooth density instead of bars. This is the formula. It might look intimidating, but focus on the intuition behind it. There are no new concepts in comparison to the discrete case. The math just changed a bit. Now, variance has one small problem. The units are squared. If x is a return measured in percent, variance is percent squared. That makes math geeks go crazy. So they decided to take the square root and call it standard deviation. We will call it sigma, which is also a common name. Now you will be happy to hear sigma has the same units as x. The war is over. If returns are percent, sigma is percent. Let's get back to the real world. In finance, when people say volatility, they usually mean standard deviation of returns. Now let us do a small example. Keep it brutally simple. Imagine an asset with only two possible daily returns. Plus 2% with probability 1/2, and minus 2% with probability 1/2. The mean is 0, because plus 2 and minus 2 balance. Now compute variance. Take each return and subtract the mean. That is still plus 2 or minus 2. Now square it and both become 4. Average them, and we see the variance is 4. The standard deviation is the square root of 4% squared, 2%. So sigma matches the typical move size. Now compare this to a more violent asset. This time we assume plus 5% with probability 1/2 and minus 5% with probability 1. Same mean, still 0, but variance is 25 and standard deviation is 5%. Same expected value but different risk. That is the entire point of the video. Expected value tells you where the distribution sits. Standard deviation tells you how wide it spreads. Now let us bring back gold and silver. Pretend both have the same average return over some period. But silver has a larger standard deviation. That means its daily outcomes are more spread out. Bigger up moves, bigger down moves. So even if the average is the same, your ride is rougher and might not let you sleep at night. And that roughness matters. It matters for drawdowns, because big negative moves compound badly. It matters for leverage, because higher sigma means you hit margin limits faster. And it matters for options, because options love volatility. So volatility is not a side statistic. In many parts of finance, volatility is the main character. In the next video, we add one more dimension. Instead of one random variable, we take two. Gold and silver do not just have their own volatilities. They also move together, sometimes strongly, sometimes weakly. That togetherness is covariance and correlation, and that is where diversification begins.